Okay, next bit. Let's now change and rearrange formulas. So a literal equation has more than one pronumeral, as we discussed before. A formula is an example of literal equation. The word literal means with letters. So example, velocity, so v equals u plus at. So velocity equals initial speed plus acceleration times the time. Obviously that's the subject, but we can rearrange it to get something else by itself. For example, you can get u by itself, you can get a by itself. So we're going to apply our equations knowledge and rearrange formulas to make another letter the subject. And of course that process is called changing the subject of the formula or transposing the formula as well, rearranging. Alright, let's do some questions. Okay, question 1. Solve v equals u plus at for a. So that pretty much just means get this one by itself. So we have to get rid of everything else so that a is by itself. So I'm going to write the formula out again. V equals u, that's a u, plus at. Well, first and foremost, let's take away that u. So we have v minus u equals at. Between the a and t, of course, there's a little tiny times. Opposite of times is divide. So to get that a by itself, let's divide by t. We'll divide this whole thing here by t as well. Okay, we now have v minus u on t equals a. And of course, that's the same thing as saying a equals v minus u over t. And that is my answer. An interesting point in this question as well, there's actually a restriction. You can never divide by 0, so t cannot be 0. Because if you had t is equal to 0 in this application, you'd actually get a math error. So yeah, that's called breaking mathematics. So you don't want to do that. So yeah, so v equals u, so a equals v minus u on t, but of course t can't be 0. Question 2. Get u by itself. This one here. I'm going to write the question again. So v squared equals u squared plus 2as. First thing, let's take away 2as from both sides. So we now have v squared minus 2as equals u squared. Now we'll just square root both sides. But of course there's plus and minus as well. So plus minus. So plus minus square root of v squared minus 2as equals u. But it looks nicer if it's on the other side. So u equals plus minus v squared minus 2as. What's my restriction this time? Well, obviously you can't square root negatives. Can you square root 0? Yes, you can square root 0. So my restriction, v squared minus 2as is more than or equal to 0. You can square root 0, but you can't square root negative 1. Well, not until extension to year 12 anyway. That's my answer. Okay. Question 3. This one's tricky. 1 on x equals 1 on r plus 1 on s. I want to get this one by itself. Okay, I'm going to write the question out again. So 1 on x equals 1 on r plus 1 on s. Again, I'm going to get this by itself. Okay, good. Step 1 is to get rid of this fraction here. So we're going to have 1 on x minus 1 on s equals 1 on r. Then the next step, I would probably get a common denominator here. So I would times s times x times s. So my common denominator is sx. So s over sx minus x on sx equals 1 on r, which is s minus x on sx equals 1 on r. Like I said, this question is really hard. Next step, I would probably cross multiply, so like this. So r s minus x equals sx. And then last step, divide by s minus x. R is sx over s minus x. That's a tricky one. Really tough. So quite a lot going on. Fraction across, common denominator, cross multiply, and then divide. That's tough. Now my final restriction. Obviously this cannot equal 0, which also means s cannot equal x. Because if these were the same, then you'd get 0 down here, which obviously wouldn't work. So that's my answer. Well, that's my answer there, but that's also my restriction. Okay, last question. Question 4. X equals square root b squared minus 4ac for b. So we need to get that one by itself. So x equals square root b squared minus 4ac. And we need to get this one by itself. I think a good step one is to square both sides. X squared equals. Now the opposite of square and square root, so they obviously cross off. B squared minus 4ac. Again, still trying to get this by itself. Next step, I would add 4ac to both sides. We now have x squared plus 4ac equals b squared, then square root. So plus minus, and that's a big square root by the way, plus minus square root x squared plus 4ac equals b, because these now cross off. So therefore final answer, b equals plus minus square root x squared plus 4ac. And that is my final answer. And restrictions, obviously that is more than or equal to 0. Because you can square root 0, but you can't square root, say, -1.